Welcome back, everybody. So today I'll show a couple of projects that I've been working on, but I want to show how to create aluminum landing gear. And let me show you some things I have done recently. I don't know if y'all are familiar, but Bossa USA makes that Stick Plus, and this is based off of their plan, which was a swizzle stick way back in the 70s. And like the Stick Plus, it's a great flying airplane, but I redrew it. This is the 25-30 size, and I put aluminum gear on it versus the plans called for wire gear. And I use a company called Cut to cut my aluminum parts, and they do a fantastic job and are very reasonably priced. This is a Pilot Champ that I've been working on, and this one's been a challenge. A lot of challenges here to overcome, and part of this was I wanted to make a hatch down here to put the battery in, and so that was tricky. And I think these two little spots here, parts here, are going to end up being solid Bossa. And we did the stringers here. Just so you know, well, I'll have a video on that coming out soon. These stringers are not nearly as difficult as you think, and they're easy to do, and of course stringers have a great effect and help you build a lighter structure. This is based off of the Doc Matthews plan 440 Bipe, but it was kitted by Ace, and it's very similar to the SIG planes. Like, they don't have the biplane. Theirs are more like the Bingo, but still very close. I changed the tail a little bit. I added some rudder. I like to try to fly knife edge when I can, and I took all the dihedral out of the top wing and put less dihedral in the lower wing to help with that. And the plans originally called for wire cabanes. I drew these in aluminum, and again, I'll send these to Cut, and I'll probably order them out of 50-53 because I have interplane struts as well. These will be strong enough, and the 50-53 they can bend at Cut. The landing gear I do out of 6061 T6. All right, and then on this is an Ace 440 or 420 kit, which is again kind of like the Bingo, but this one had a shoulder wing. It was made for a 24 stroke. Of course, I'll probably fly with a 20 or 15 to 22 stroke easy. But I'm going to show how I do landing gear on here. And that way, if anybody has, if you want it's hard to find landing gear anyway, but Cut is reasonably priced. And if you do send them a lot of projects, it's even better because the price will go down. All right, I need a sip of the coffee this morning. So I'm going to go ahead and create a new component here. And normally I do the landing gear way after the phase where I'm at now. But I got up this morning and I said, I think I'm going to make a landing gear video. Or at least an aluminum part video. But we're going to call this landing gear or undercarriage for you people in the rest of the world. Yeah, for some reason the US, we call everything and do everything different. And I don't know why. Okay, so we created a new component for this, and I don't know if I have a, yeah, there we go. Nope, not that one. Okay, so one of the things, a quick note about landing gear, if you're doing your own design and you don't know where the landing gear placement should be, it is important depending on the type of gear. So if you look at this, the axle is about at the leading edge on the tail dragger, or conventional gear. And if you put it too far forward, it's going to take longer to get off the ground, and it may just hop. And then if you look at, I don't have an easy diagram of one right now because I don't like conventional or tricycle gear. But tricycle gear, it really doesn't matter where the nose gear is. But it is important where the center of the wheels are on the main gear, and that is, it should be 15 degrees off from the center of gravity. So like in this instance, I'll go ahead and just create a little sketch, and I'll show about where it should be. And if we go at the same height that we have here. And of course, the height of your gear is all predicated on what props you're using. You want to make sure you have good ground clearance. You know, an inch or two is better, or for those like 2.5 to 5 centimeters, or 25 to 50 millimeters. So anyway, if I draw a line from here to my center, this should be about 15 degrees back. So yeah, if we go to 90, then we're going to go to 105, which is adding 15 degrees to, so about right there. That's where the center of your axle should be on a tricycle gear airplane, right in this spot. And that seems to work pretty well. That's a general rule, and it does work well. It's far enough back off the center of gravity, you're able to rotate on your takeoff easily. If you go too far back, it's going to take longer to rotate. If you go too far forward, then it's going to rotate too soon. And well, rotating too soon is worse than rotating late. But anyway, you want to avoid that. Okay, so that's just a quick idea about landing gear placement. So now what I want to do is I'm going to create, I'm going to work this in the sheet metal environment. And so I'm going to go to the sheet metal environment, and the first part I'm going to make is not in sheet metal. So we're going to create a sketch, and I end up converting it to sheet metal because it's easier to control the thickness. So let's draw a center line here. We're going to make this a construction line, and that's just to help us stay located. I'm going to turn that one off for now. And then this is where the landing gear block is, and I'm not 100% sure at the width, but I only want to go on one side, and then I'm hoping to mirror it. Normally I do it on two sides, but I'm hoping I can just mirror this and join it or combine it and make you know, it's easier to do, less steps. So I'm going to put this in line with that line on the fuselage. And let's look at the side drawing really quick and get a get this width. Oh, I'm way up there. That's all right. Let's put this. I just want to get that to about it close, and you can make all your adjustments however you want it. Yeah, I'm gonna do an offset. Since I'm way up here, I'm going to do an offset extrude. That looks pretty close. Okay, so that's really all I need on this sketch. And again, let me go back real quick. You really got to define these sketches. So let's put a dimension there, and then we'll put a dimension here, and that should lock all this place. For some reason it didn't. That should be the same, right? Yeah, that is. That should be the same. Okay, let's find our origin, and then we'll make a measurement from the origin. There we go. Now it knows where we are. Okay, so I'll finish this sketch, and let's hit the home button here. And what I want to do is I want to make this the thickness of the material that I'm going to use, and I'm going to use 1/16 inch 6061 T6. Let me turn the canvases off for now, and I'm going to turn this fuselage off for now. And I'll make sure I get that. And then let's turn these canvases on, and we want to do an offset. So we're going to do this offset, and it wants to know how far we can do it to an object, which in this case would be easy, but I may not be able to select the object. Okay, now we want to go down 1/16. Cannot extrude the object. Extrusion failed. I don't know what's going on there. Let's see here. I'm gonna do a distance. I'm gonna guess it's 3 inches, and we can make this adjust. I should have measured this before, but that's all right. 2.9. 2.95. All right, that's 2.93. There we go. That's pretty close. So, and then we want the distance to be a 16th, so 0.0625, or 1.5 millimeters, or 1.6 millimeters to be closer to accurate for the rest of the world. And there we have our little base to our landing gear. It looks like it's a little short from what was on the plan, but that's fine. We can fix that. We're going to extrude this side. And of course, you can measure more accurately from the beginning, and that's fine. All right, I think that's going to work. Okay. So now we want to convert this part. Let me change the appearance on this fuselage so it's easier to see. You can hit A for appearance, or you can right-click. Let's go here. Wood solid. Unfinished. And we'll download this one. That's how you download them if you don't have them already downloaded to your computer. Let me just go up here. In case y'all were wondering how that happens, this is how you change your colors, your appearances. And just so you know, you can change the appearance, but that doesn't change the actual material that you're using. I'll show later in another video how to do that. I might be able to just hit. There we go. That did the whole thing. Okay. So let's close that. Now we're going to convert this to sheet metal, this piece right here. And I'm going to change it to aluminum so it has the aluminum K factors. And it says note wall thickness will be changed to 0.063, which is what we want. And there we go. So now, like the sheet metal tools in Fusion are really nice and simple to use. So now, one of the things on this plan, it doesn't give me an accurate dimension of the width of the gear. So just so you know, as a reference, the landing gear width is about 25% of the wing. So I'm going to run over here to Chrome, and it's 48. So 12 inches is about the width. And what I'm going to do, I'm going to make a sketch to help guide me through that. I'm going to create an offset plane. Not there. I'm going to create an offset plane on this face. All right. And we're going to create a sketch on there. And this is just going to give me some guidelines when I do my bends to help me out. I don't know why Fusion does this weird thing with moving the center. I'm not sure why it does that, but I'm just going to project this point. And all we're going to do here is guidelines. So I'm going to bring that down and come over here and see where the center of the axle is. It looks like it's about right there. We want that to be 90 degrees. And this has to be 6 inches. 6 inches wide. And you can go one way or the other with that. But the wider stance, of course, it's going to be a little more stable. But if you go too wide, then it's going to be harder to turn. So finding that balance. So anyway, this is where the center of my axle needs to be and the center of my tread. So my gear should come about right here, a little far back or whatever. All right, so that's going to be our guide. So I'm going to come up here and create a flange. And I'm going to select this edge. And as you see, it automatically creates the bend with the bend radius because we selected aluminum. And then we're just going to change this angle. And We're going to see what where that takes us. We're going to need a little less. $30 looks pretty good. And on this gear, I'm probably going to use an inch. So I want a 1/2 inch to be dead center. I'm going to use an inch on this last flange. So let's go up a little bit more. You can turn the snap to grid off. Layout grid locked. I don't know why I'm snapping, but anyway, let's go 25 degrees and see where that takes us. It's probably 27. Let's try that. That's a little better. And then you always can come back and adjust it. So 27 degrees, and then since there is a chamfer on this part, I'm going to hit chamfer, and I hit 2 distances. You can do distance and angle if you know that angle, but I don't know that angle. So I'm just going to do 2 distances, and we'll put that there. And this, it will warn you when you get too close to that curve or that radius, that bend, because it won't take the chamfer into the bend. But it's going to get us pretty close like that. And we're going to say okay. So now when we make this next flange, it's going to be that width. So I want to make this 1 inch, and then we got to change this. To get 90 degrees, we need to subtract 27 from 90, so that's 83.63. Is that right? Yeah. And there we go. And that's pretty close. I may actually change this to 3/4 of an inch. And that should work. And I probably need this a little bit longer. So I'm going to go back here and edit this flange. So I can go edit feature. And I just want to make this a tad longer. And we'll see where that ends up. That's pretty good, because we got the width of our wheel and everything. So there's one of the legs of our gear. And that's pretty close to center. And we can come in here and we can put, this is a chamfer here. Then it has a radius over the bolt hole. And you don't have to follow these, but I do like to put fillet. I do like to put fillets down here just to help from keeping the gear from catching the grass. So that looks good. You can go all the way up to the top, right to that bend. Then come in here and get the fillet tool. And select that. Select that edge, and let's make this round. And that's probably good. I want to keep this a little bit longer than what they had on the plans. All right, so there you have it. That is one side of our landing gear. Now what I want to do is I want to mirror this. And again, I talked about this. You can hit S on your keyboard, and then you can search in this little box. You can go to mirror, and then I have an X here. It's because I added it to my design shortcuts. But anything you want to design or want to add to your shortcut, like if you want to add appearance, you just hit this little thing right here. And in this design shortcuts, it has all the tools. And you can just select whichever one you want that in this little shortcuts box. You can also go to create, and here's mirror here also. So what I want to do, I want to mirror bodies, and I'm going to select my bodies. Then I'm going to select my mirror plane and select that. When you select the mirror plane, the origin will show up. So now I have both sides. I think I'm going to try this. I've never tried this before. So I'm going to go to combine. And did it do it like without it? It actually did. It joined those two pieces together without me having to hit combine. I must say, that is amazing. Okay. So now with this, we just need to put holes for our axles, and you want to do this. Send Cut Send will cut all the holes for you. I'm telling you, it's been a great thing, and Send Cut Send is not paying me anything. I just like them that much. My nephew turned me on to them, and I use them. So if you notice, if I grab the circle tool, and then when I get this circle here, where it is, that means that's in the dead center of the radius of these fillets we have here. So I don't know what size axles I'm gonna put, but I can always wallow them out. And so that'll be the hole for that. And then I'm going to extrude this. And I want to go this way. I'm going to select the distance. And if I select distance as all, it will go through every object or every body that is visible in your design screen. So it's pretty handy. And then even if you change any of these bends on your any of your flanges and change the angles or the length, it's still going to, it'll adjust the hole where it actually still goes through all. And you don't have to worry about what you put outside of this. It won't do it because they weren't visible at the time. So that gives us our axle holes. And then what's really cool, and like I said, I'm too early in my design process when I normally don't do this, but I will create a sketch here, and I will have my holes drilled for my mounting bolts, and I don't know what size they're going to be right now. And I'm going to make a center line here. That's going to be a construction line. And I'm going to go ahead and do the same thing here. And let's make that a construction line. So now I can just mirror this. And we want to mirror it this way. Okay, and then I want to mirror this. Mirror it this way. And there we go. And that's where our mounting holes are going to be. And what I will do, I'll have my mounting blocks already drawn into Fusion. And then let's finish the sketch. And then I can go in here and cut these holes. And it will go through the bottom of the fuselage and my mounting blocks. But I don't have my mounting blocks there yet. I don't want to hit all or go through all. If I go up here and I go distance all, well, I get holes on my top piece. I don't want holes there. So I need to turn that one off. Let me find it. This is why you name things, but I haven't gotten to that point either. Okay, so now if I hit all, it's just going to go through that right there. And if I have my mounting blocks, I would do it there. I'm going to go through them as well. So hit OK, and I have my holes lined up on my fuselage, and I have my holes lined up on my gear. So now what I want to do with the gear is I want to create a flat pattern of this gear. Now, Fusion only allows you one flat pattern per component. So like on my cabanes, like on these cabanes right here in my interplane struts, those are all separate components, like especially these, because I have a left and a right. So I had to create separate components so I could create flat patterns for each of those. So just remember, you're only allowed one flat pattern per component. So let's go back to the sheet metal environment. And then right here at the top is create flat pattern, or you can come down to here and create flat pattern. You will have to click on a stationary face, so Fusion knows how to unbend this. And I talked a little bit about unbending metal parts in the other videos on the fuselage sides, but this is a little bit different because we're creating a flat pattern. So we hit OK, and as you notice, it shows our bends, and this shows us how much curve we have to have in the bend, and there we go. That's our flat pattern. So I don't have anything to change here. You can change things and edit things in the flat pattern, but they won't translate to the 3D drawing. If you change things in the 3D drawing, it will translate into the flat pattern. So just remember where you're making edits and changes. So I'm going to save this flat pattern, but here I want to export it first as a DXF. And convert splines to polylines, so that means they're all connected. And go here, hit OK. And it's actually, I'm going to put it, not in here. Where am I going to put it? Oh, this is my new computer. I forgot. I don't have my other folder on here. So this is going to be the 420 landing gear. Undercarriage for you people in Britain. So that I saved that there. And so now I'm going to come over here and I'll show you Send Cut Send. It's really a great product. And there are other companies that do cutting, but Send Cut Send is the least expensive option that I've seen. But it's a great program, and you can see I've got some other stuff here. So I will just add new drawing here, and I'm gonna go to that the model airplane folder where I put it. Here it is. It brings it in. Now, one thing that Send Cut Send cannot bend is 6061T6, but they can bend 5053 and the other one, or 5052. But I want my landing gear to be strong, and you can bend landing gear cold. You just got to be real careful you don't break it. And I want this thickness, and so here, if I buy one, they're $4.13 each, which is really cheap. And what I like to do is gain, so I just say I'm gonna buy one. So the minimum, if you want deburring, is free. They also offer powder coating, and they can tap those holes, but I don't need them tapped. I just need them drilled. And then I go here, and then I'm gonna hit View Cart. I got a couple of things here I need to remove. Let's take that, just so I can show you what the cart looks like. So their base price is $29. And no matter what, the base is $29. This is not in addition to how many parts. Because let's say you order 10 of these, well, the price drops down to $2.93 each, and it's $29.30. So it pays to send a whole bunch of stuff at one time to them, and it's really reasonable. At $3 for a custom cut aluminum part, I don't want to pull out my bandsaw and cut that. They're worth it because it's accurate and everything else. And I have had them do bends on the 5052 material, and they do a fantastic job. But anyway, I hope this video was helpful to everybody. If you have any questions, just holler at me. Thanks again.